We're going to look at how to find the equation of a line given some of the line's properties. And when I say the equation of a line, what I mean is the slope-intercept form of the line, the y equals mx plus b form. And I want to discuss this for just a moment before we get started. In this equation, it looks like there are 4 variables, but in fact there's only 2, y and x. Those are the things that can change. When you talk about a line has only one slope and one y-intercept, okay? So m and b are literally numbers that you have to find somehow, and x and y are the variables. So a typical form of a y equals mx plus b, or a typical example might be y equals 2x minus 3, right? The variables here are y and x. They're necessary to leave that way because they could represent a multitude of different values, right, as ordered pairs. But the 2 and the negative 3, those are fixed values that we can't mess with. So keep that in mind. When you go to find the equation of a line, we're looking for something like this, where the variables are x and y, and the slope and y-intercept are determined. So that's what our goal is going to be here. Let's look at an example. So here's a particular example. We want the equation of the line that passes through these 2 points. So if I want that, I need the equation to be in this form. So I need the slope and the y-intercept somehow. Well, luckily for us, we have 2 points, so it's very easy to find the slope, and I'm not going to go through how to do that. That's in another video if you want to go watch a video on how to find the slope. But the slope is negative 5/7. Furthermore, this point right here has to be the y-intercept, because a y-intercept has an x-coordinate of 0. So that's how you could recognize that this is the y-intercept. So the 9 is the b value of the y-intercept. So the equation of this line is y equals m, which is negative 5/7, times x, plus b, which happens to be 9 in this case. And that's the equation of this line. So that's a fairly simple one. Let's try another one. This one's a little bit harder because neither one of these is a y-intercept, so we can't plug. We don't know our b value right away. But we know it's going to be y equals mx plus b. We can find the slope here again because I have 2 points. Our slope happens to be 2/12 or 1/6 using those 2 points, so that's m. And now we have to find b. We're not given that. The good news for us is if I want to find b in this equation, I have to plug a value in for y, m, and x. Everything else has to have something plugged in, and then I could find b. So luckily for us, we know m. Right, we know m, so that's good. And then each of these ordered pairs is on the line. And in fact, each of these ordered pairs is simply an x and a y value. So I could take either one of these and plug in the x and the y from that point. It doesn't matter which one, you'll still get the same b when you solve. So I'm going to plug in the 7 and the 4 for x and y into this equation. So I'll plug in the 4 for the y, the 7 for the x, and the 1/6 for the m, and then I'll solve that equation for b. So I have 4 equals 1/6 times 7 plus b. So I have 4 equals 1/6 times 7 is 7/6. Now I need to subtract 7/6 from both sides, which is 17/6 equals b. So now we know b is 17/6, we know m is 1/6, so now we come back, we write the equation of the line, y equals m, which is 1/6, times x, plus b, which is 17/6. So this is the equation of this line. Now notice I didn't put the 4 and the 7, or the 7 and the 4 back in again for x and y. Remember that this line has a lot of ordered pairs on it. Here are 2 of them, in fact, but there's an infinite number. X and y are variables here, so we have to leave those as x and y because they could change. But the slope and the y-intercept, those are the same no matter what. And that's how you find the equation of a line given some of its properties.